Let's continue with 3D work. In this next step, we'll drag in an OEM assembly from a supplier into the assembly and position it relative to the assembly sketch. As part of our process, any OEM data received should contain simplified representations of the part or subassembly. This process is quite simple but yields some drastic performance increases. Remember that squeezing every drop of performance from our system is important when dealing with massive assembly designs. Solid Edge allows us to easily place 3D components directly to 2D sketches. Since the layout defined the spatial locations, why not have that same layout drive any changes? We'll call this the hybrid approach to assembly design. In this case, we're just creating some simple alignments between the faces of our subassembly and the sketch elements. Finally, we'll add a alignment relationship between the bottom of the foot and the plane of the sketch. A quick dimensional change of the layout sketch shows how the 2D elements can set the position of this newly added vendor assembly. The larger the assembly, the more common having similar parts becomes. The number of conveyor sections in this assembly is a perfect example of this. While we can pattern and place these components to replicate them in other areas, a natural workflow would be to just take one of these and put another one over there. The component move command in Solid Edge has an option to move a component while making a copy of that part or subassembly. Here we'll simply copy a small conveyor section to a new location. We're going to use the linear move option and the copy. We're going to move it from one key point to another key point. Next, we'll rotate the conveyor into position so it is in the correct orientation. We'll see other uses of this command and how it is an extension of patterning later in the demo. This precision table seems to lack precision, but remember it was placed in a simplified state. We can toggle the display to show it in its original fully designed form. Solid Edge was designed and architected for performance, and having the ability to switch between faster, accurate representation of parts and subassemblies is key to large assembly design. Notice that Solid Edge simply turns off the edges of the parts during rotations for faster display. This is just another proof point of Solid Edge's commitment to performance optimization by adjusting the display to maximize performance while retaining as much detail as possible. Let's design the boiler next. If you'll remember, we created a 2D sketch representation of the boiler earlier in the demo. When we published the assembly, the design sketch elements were copied into the individual files to which they were designed. We could, of course, designed all these components from the sketches, but since this model exists, we'll simply replace it. We use the sketches during the concept or layout phase to determine its location, and then when we replace it with the actual 3D assembly when it's designed or supplied. Remember that this virtual component was published to a 3D file, so replacement is a simple process. The new design drops into place exactly where it should be. So now we've begun to see how productive Solid Edge is for plant layouts. Solid Edge's unique 0D workflow for creating and working with 2D layouts during a conceptual and planning phase provides a smooth transition into full production design. While this demonstration is centered around plant equipment and layout, the tools and methods in Solid Edge scales to any assembly design. Some key tools and an optimized architecture make Solid Edge the best solution for assembly design. Assigning designers to tackle. So now that we've added our boiler, we're going to go ahead and show all of the rest of the components that we have in this assembly, including the plant floor and the walls. And you can see from our 2D sketch we were able to get this 3D model showing the complete layout and the workflow for our plant layout. As we begin to zoom in on the model and zoom around, you'll see the conveyor sections that we added and the turntables, as well as the robotic arms. Assigning designers to tackle plant design can be done from a file standpoint, where a particular engineer managed a particular subassembly and so on. Zones in Solid Edge takes design management to another level. While most systems are organized in separate assemblies, it's often important to know what other systems interact with it. So, for example, if we're the engineer responsible for the boiler, we may wish to know what other systems are going to be in close proximity.